And how about a little review on functions? We're going to be working with a lot of functions as we continue through the course. So, what is a function? Well, it's just a rule that takes an input, does something to it. So it manipulates that input according to whatever that particular function rule is. And it gives you one and only one output. So you probably remember from somewhere that something special about a function is that each input has only one output. Okay? But other than that, I mean, here's an example. Here's our function. This guy happens to be a quadratic function. And what I need to do here is I need to find these values. In other words, I need to evaluate the function at each given input value. So this first one, the input here, that's the x. Okay, so we're saying when x equals 0, so I plug 0 into that function for x, so the result is 5. So the f of x can be interpreted as the y value, okay? So we could say when x is 0, y is 5. So really, I mean, I found a point, a coordinate pair, on the graph of that function. Okay, if I was going to actually graph that quadratic function, which is a parabola. Okay, so another way of reading this guy, when x is 2, what is y? Okay, so I take the function here and I plug the x value in. I have to be careful with my rules. So you see here, that exponent, remember I apply exponents before I do multiplications. I should have kind of blocked this off like that. This organized a little better. So I'm thinking about what order to do things in. I'm thinking of that PEMDAS. So I do exponents before multiplication. So I need to apply that exponent before I multiply by the -1 in front. Okay, so that means I have -4 minus 6 plus 5. Okay, so what is that one saying? Saying when x is 2, the y is -5. So if I wanted to, I mean, I found a point, another point on the graph of the function. Okay, a few more. Exponent first, -1 quantity squared is -1 times -1 is 1. But then I have that negative in front. F of A, so I mean if I'm plugging a variable in, that means my answer is going to have a variable in it. But oh well, so that's all I can do for that one. But sometimes expressions like this can be helpful for calculus. So now we're going to replace x with a plus h. So I'll have negative a plus h squared minus 3a plus h plus 5. Okay, so I have to apply the exponent here before I multiply. So be careful, a plus h squared is a plus h times a plus h. So I have to use that FOIL process. plus AH plus another AH. So there are two AHs and then an H squared. Distribute the negative. And then I look for any like terms, which it doesn't look like there are any. So why would I want to do this? Well, again, we're going to get to that. I think there's even one more thing we're going to do a little later in this section. But those come up in calculus. Okay, what about a rational function? So a fraction. So I'm going to plug 0 in. Just leaves me 2 over 1, so 2. Okay, so here I have 0 in the numerator. So 0 things divided by 3 people leaves me with 0. Okay, it's when I have to be careful that I get 0 in the denominator. Okay, nothing too exciting there. Oh, let's try the fraction. 2 minus a half, then a half plus 1. Here's a cool trick. So I'm going to take that denominator, the 2, and I'm going to multiply by that 2 top and bottom. So look what happens. Okay, 2 times 2 is 4. 2 divided by 2 is 1. 2 divided by 2 is 1 plus 2. So I'm actually able to get rid of those smaller fractions in just one step. So that's kind of cool. We're going to continue to use that trick. So how did I do that? Again, I said, okay, 2 times 2 is 4. 2's cancel, so that leaves me minus 1. In the bottom, 2 times a half is 1, and 2 times 1 is 2. Let's try the f of negative 1. Okay, so that one's kind of special. Because this is the one where you get the 0 in the denominator. So it doesn't make sense to divide by 0. Okay, that's impossible. We can't divide by 0 people. So we would say that expression is undefined. Or we could say does not exist. Okay, 0 is not in the domain of that function. Okay, here's an important one for calculus. So we're going to get to this towards the end of the semester as far as why is this quantity important. So for now, we're just going to see if we can do the algebra part. This part you've probably done before in an algebra class. So find the difference quotient. Okay, so we have this template that this is the formula for any function. So what changes are the quantities in the numerator, because those are dependent upon the particular function. So the first thing I have to find is f of a plus h. So I'm going to plug a plus h in the function. So I'll have 2a plus h squared minus a plus h plus 1. Now I need f of a. So now I plug a in the function. 2a squared minus a plus 1. So now I have to do all of the algebra. So remember, a plus h quantity squared, I have to do the FOIL, right? Distribute the negative. Okay, I'm looking for a lot of cancellation. All right, so let's see, the a squareds cancel. What else? The a's, the 1's. So a 4ah, a 2h squared minus an h. So what you'll notice is this h in the bottom, with these difference quotient problems, that h in the bottom always cancels. So what I can do is I can factor the h out in the numerator, and then I'm actually going to be able to cancel those h's, and there's my difference quotient. Okay, so like I said, we're going to talk at the end of the class about why this difference quotient is important. For now, it's just a matter of doing the arithmetic, the algebra. Okay. Different function, same formula. So this formula, right? Okay, so the bottom always has the h. The numerator I have to fill in. So f of a plus h, 2 over a plus h minus 1. And then f of a, 2 over a minus 1. And then I simplify. So I'm going to do that same trick. So here's what I'm going to do. I'm going to look for the LCD. So you see, I need one factor a plus h minus 1 and one factor a minus 1. So I'm going to multiply by that whole LCD, top and bottom. So look how this works. When I distribute this here, this cancels with this. So that'll just leave me the 2 and the a minus 1. Okay, in the second fraction, this cancels that. So that will just leave me the 2 and the a plus h minus 1. Now the bottom, I'm just multiplying straight across. Okay, the denominator's already factored. I already have 3 factors multiplying. So that's done. The numerator, though, I still need to distribute so I can combine the like terms. Those cancel, those cancel. So negative 2h, and then h, a plus h minus 1, a minus 1. So now I can divide top and bottom by h. So indeed that h cancels. And here's my difference quotient. So what else is in this section? Here's a little review of find the domain. Okay, so the domain is the set of all allowed x values, all inputs. So all inputs for which the function is defined. So sometimes the easiest thing to do is to look at the function and go, well, what kind of number would give me an error? So the thing with a fraction is I can't divide by 0. So the error would occur if x was equal to 5. So that means the domain, in words, is all x except 5. So how do I write that? So there are a couple ways. Here's we call this the set builder notation. And I'd say the set of all the x's where x is not equal to 5. Or I can write this in interval notation. So for that one, it can be helpful to think about a number line. So if I want to say everything except for 5, that means I have all values from negative infinity to 5, union, that means or, all values from 5 to infinity, with 5 left out, with an open parenthesis. So here's my domain written in 2 different notations. I should know how to write both. Okay, again I have a fraction. So what I'm going to do is I'm going to look at the denominator. Let me factor that. Okay, let's see. Adds to 1, multiplies to negative 6. Is it plus 3 and minus 2? Looks like it. Okay. So the domain, all the allowed values are going to be all the x's where x does not equal negative 3 and x does not equal 2. Okay, that's the set builder notation. Okay, let me write the interval notation. For that one, I think, again, it's helpful to think about a number line here. So I want to say everything but negative 3 and 2. So actually, there are 3 intervals. Negative infinity to negative 3, or negative 3 to 2, or 2 to infinity. What about a square root function? So square root function is a little different. I don't have a denominator. I have to think about what kind of numbers can I take the square root of in terms of real numbers. Well, non-negative numbers, right? So whatever it is that's underneath the square root needs to be non-negative. So in this case, wouldn't the domain just be all the x's where x is greater than or equal to 0? Because the only thing underneath the square root is that x. If I was going to write that in interval notation, it's the set builder. Okay, for the interval notation, think about a number line. I want to say start at 0, zero's included, and go right. So to include 0, I'd use a bracket, 0 to infinity. Okay, here's a fancier square root, but the good news is, I still follow this same rule. So I say to find the domain, whatever is underneath the square root has to be non-negative, has to be greater or equal to 0. Okay, then I just solved the little inequality, so subtract 9. Just be careful. Remember with inequalities, if you multiply or divide by a negative, you have to flip the inequality sign. Other than that, I solve it pretty much just as if I would solve an equation. Okay, so be careful then, because in the next step here, when I divide by this -3, I'm actually flipping the inequality. So the domain is going to be all the x's where x is less than or equal to +3. Or, thinking of the interval notation, here's 3, 3 is included. So this would be -infinity to 3 with a bracket. And a couple more, so let's see. So here I have to combine the two ideas. So here I see two things. I see I have a fraction, so x cannot be 1, okay? Because then I would be dividing by 0. And whatever's underneath the square root has to be greater or equal to 0. So subtract the 4, divide by negative. Be careful there, I have to flip the inequality. So how do I combine this to actually write out the domain? I would think about a number line. So I want to say x is less than or equal to 4. So that'd be everything over here, right? Except that x cannot equal 1. Okay, so I'm leaving out 1. So how would I actually write out the domain? Well, if I want to do set builder notation, I'd have to say the set of all the x's where x is less than or equal to 4, x does not equal -1. The interval notation, I can look right at my number line. -infinity to 1, 1 is not included, it gets a parentheses. Union 1 to 4. 4 is included, it gets a bracket. That one's a little more interesting. What about number 6? how do I find the domain of this guy? Well, be careful. You don't want to immediately start doing algebra because this guy does not have a denominator. It does not have a root. This is just a quadratic function. I mean, if I was going to graph this, doesn't it just look like a parabola shifted down 4? I mean, what's the domain of that? Doesn't that extend all the way across the plane? So isn't the domain of this all real numbers? Here's how you write that in set builder notation. You say set of all the x's where x belongs to. And then we use R for real numbers. We put a double line to say set. X belongs to the set of all real numbers. That's a nice little review of